Okay, this is Wally's drive system. The way that I've designed my drive is it's nearly all 3D printed, apart from the main members that are running through, which are 20 by 40 aluminium extrusion. You can get this in either clear anodized or matte black anodized, which is what this is. Again, this uses the 608Z diameter 22, diameter 8, ID and 7mm wide bearings, common off of skateboards and scooters, that type of thing. So we're going to be using quite a few of those. I'll go through one track assembly side. I guess this is how it's going to look when it's done. I've still got to route my wires through and solder those up. So one of the first things to be aware of is this is still a test, but I'm pretty confident. I've driven this around a little bit in the shed and around the place. Still need to take it out to my work and give it a good run through, just to test if there's any strength issues. Something I have done, this is a single part down the bottom here. This is a bolt-on piece here. I'll flip it over in a minute and show you. This is a single piece insert that slides into the bottom part. And on the inside of this is some more 20 by 40 extrusion in here. So there's a piece of 20 by 40 that runs from about down the bottom, inserted into the bottom piece, all the way up to the top here. There is a hex head screw that I have buried in there that I've tapped into one of the ends of the holes. So an M6 tap I ran into the end of the hole on this extrusion. You can just run an M6 tap into those and you'll thread those. These are 3D printed brackets, a 3D printed cover. The top piece I printed with about 5 walls just to ensure that it's strong enough. The weakest point cross-sectional area will be here and in there. The attention point is that this can slide, so as you can see down in here, this part can slide up and down. It's bottomed right out now, and with the 32 tracks on it, it's loose enough. If I needed more clearance, I'd print another tread piece to insert to give more slack, and then I could tension and slide this whole mechanism up on the top member here to give the tension on the track. Because with a track system, you don't want it to be too tight or too loose. Too tight and you get too much friction. Too loose and it won't drive. You'll draw too many amps and blow up your motor driver. This piece here is 2 screws that thread into the bottom. I'll try and flip this over by hand so we can see the bottom. So in the bottom, through this hole, there's 2 socketed cap screws. Again, onto the end of the 20 by 40 extrusion, I drilled and tapped. Sorry, you don't have to drill them, you just have to tap them. Because they're already diameter 5, just an M6 by, I'm trying to remember the pitch, 1.25 maybe, thread, whatever a standard M6 thread is. So 2 tapped holes into that 2040 extrusion here, so that I could bolt up through the bottom here. In the bottom of this piece, which is the bottom part, the main member, again, this needs to be really solid. I'm trialing this as a fully 3D printed item at the moment. If I have issues with too much force on the track, I'll probably end up having that a tube that runs through the middle there, diameter 20 tube or something, and think about how I route the cables out a different way from the hub motor. So this piece is just a cover really. It screws onto the bottom here. This piece glues on. This one glues onto the inside here of this bottom plate. And there's also 2 dowels on the top into this piece behind here. But they aren't glued into that face. It's just to give it location to any shear force or stop that pulling. I've allocated and allowed for diameter 8 shaft to go through here in case I find that the track's buffeting too much. Then I can add some road wheels in here with some more bearings and some shaft that would just run between the 2 cleats, I think they are, at the bottom of the drive system. So at the moment it doesn't have any road wheels. but if I find that he's bouncing around too much from the front of the cogs running on the ground, then I can put some road wheels on. If I ran a diameter 22 bearing, the same bearings, with just a TPU sleeve on them, like a rubber wheel, diameter 24 I think it is, that will give it about 3 millimeters further down than what the drive distance would be on the edge of the sprocket here to the ground. So it means that it would sort of lift it onto the bottom here rather than driving on the sprocket wheel. So I'll flip it back up again. So these, again, this screws, so this is glued into this piece. And then there's 2 screws that go into this one. So there'll be heat inserts into here. And then there's just 2 screws on the inside there. I'll flip it over. Now, the wheels themselves, they have an M6 nut, hex nut, that just pushes down, and there's, in the hole that runs all the way through to the center, is the retaining feature. They'll go onto some shafts that go into this. I should have probably taken the shafts out to measure the length. And these are the grub screws. They're M6 by 20 millimeters long. Just enough that these are 304 stainless, but just enough that you can get an Allen key down into here. These don't need to be tight, they just need to retain it on the shaft to stop it wandering off. I'd probably suggest putting in a bit of Loctite just to stop that any vibration coming loose on the track. So, drive sprocket. Now, this is the hub motor. I'll put a picture up of this as well, of it in pieces. I've got 2 hub motors. Off of hoverboard wheels. These cables originally came out the end of the shaft. So I've had to modify this by carefully drilling in a hole. You get a ruler into the axle, and that hole from the end of the axle, 40 millimeters from the end to the center of the hole. I started by drilling that with, it was probably like a diameter 4mm drill, and then a 5, and then an 8. The 8mm shaft was just something that, this was part of a precision bolt. So they're a ground bolt that have a thread on the end. I actually stuffed this one up, and I had to then add this piece on the end to give it another extension, because what I needed to do was have that shaft stick out the end 40 millimeters. Let me focus on that. It's probably 38 or 39 millimeters. So that once the goes through the back here to retain the wheel, then this can go on to the side, and I have just enough sticking out on the face here that the thread would retain that in and clamp on the inner race of the bearing. So you can see that on this side, if I take the cover off, these are just going to get hot glued on. That's the nut that goes onto that. I'll take this one off. So what I did was I pushed this ground shaft, which was a bolt, a ground precision bolt, and it has a thread on the end. This is diameter 8, and that I pressed into the end of the axle from the hub motor, which it's not an easy process. I've got a trade background, so metalwork's my forte. Now I just work in plastic. But again, I'd put a drop of Loctite on this, and then that cover will pop on there, so it can say B&L. Now, I'll try to do a bit of this by hand. There's 4 heat inserts that go into the back here. They're a little bit tricky to get in, but not impossible. They have a cover that goes on, and the cover has a flat on the back, and that'll be the part that clamps against the flat on the motor. when these were on a ride-on scooter, you have to remember that they're all clamped from one edge, and all the load is trying to stop this doing that. I'm sort of using that to stop the rotation now, so that the motor wheel can spin, and that flat has to line up facing out. Go in the hole. Okay, just push that all the way through, and then on the outside, this has got two bearings in this wheel, one there. There is a spacer, a 3D printed spacer that goes in the middle, just to stop them crushing together. Bearing on the outside. This will go on. I'll have to get that spacer to line up. Okay, once I manhandle that on, that'll go in. And then what we need to do with the cables is we need to push, not all of them at once, it's going to be a bit impossible. They go up and through the hole there, and they run through a channel in the print and come out just past the back of the cleat, and then we'll come out where the bottom motor housing is. And what I've done with this one, this is just two set of dowels. So we can get it apart. This has an internal cavity where the wire will come out from that hole in there, run along the inside of this cavity, and then pop up out the top. This has the T-nuts, M4 T-nuts. So you can buy them like this. You can get a pack of those. I can't remember exactly how many I bought, but you will need the M4 T-nuts for 2, 4, 6, 8, 10, 12, 14, 16 at least, 32 because you got the other side to do, 40, maybe 50 of those. I've got some in here as well, I've got some springs for the body. These are 3D printer bed springs. I'm just trying out different sizes for the weight. I keep adding a little bit more weight. So once that cable comes out of there, you can line up the cable in the slot here, and then we can just orientate that T-nut if it wants to play. Pushes up against that, and then the cable will come out through the bottom on the inside of the body, so you won't see any cables at all from underneath the drive, and it protects it from getting caught in any of the drivetrain, which is one of my other things to think about. Alright, so I'll push these cables through and then we'll have a look again. Okay, once you've wrangled all the cables, put the bracket in the back. This is where the cables will go through at the top when that goes up and back into the cavity. I'll come out the side here, underneath the edge. And like I said, you can then get your other part, route your cables through. Again, a bit tricky one-handed. If I can do it one-handed. So that'll hold that in place. Put the cables in. I'll have to terminate all the ends of these, of course. Oh gosh, just go in there. We'll have a look from the other side. Use our cable management. Stuff it in the hole. Like that. And then our other bracket. Make sure that's T-nut sticking out. There's a couple of dowels I've got in this one. You could put all of them in. I've just got 2 at the moment. It seems to be fine. Click that on. Do up the other Allen key. at that. And the bit down there, I'll get some black paint and paint that. The bit that's at the top, I'll group that together, and then these will go up to wherever you want to mount your motor driver. The cables here are the three for the 3 phases of the brushless motor, and the other 5 are the Hall effect sensors. I think it's 5-volt ground and 3 Hall effect sensors that are on the brushless motor that was there. The motor driver I'm using on my layout at the moment is just these, what's the number on there? Ooh, upside down. ZSX11H. There was a few little tricks to this motor driver if you do get these off of Amazon. One was I had to put a bridging, I think it's on the bottom, I had to put a bridging joint to allow this to be PWM controlled from the side here, but it is in the instruction. It was just a little bit of a berry to find it. So then I can send 2 signals in here. There's not 3, I'll just use this cable. There'll be 2 going, one for PWM out of the ESP32 or Arduino, whatever you're going to use, and then the direction one, so whether it's high or low. The other one in here, sorry, this was direction 1 here, and the other one was PW, the signal for the speed. And this will be the 3 connectors that I've got coming off the motor. I've just got a quick disconnector there, and there'll be a connector here for the Hall effect sensors. So back to the wheels, we'll measure these shafts. There'll be 1 shaft for the larger idlers on the front, and this one is 125 or 126 millimeters long. That one will go into these shafts here. We put an M8 washer so that when that goes in, do the grub screw up on the inside as well. The washers to ensure that, again, don't over tighten these, they don't have to be too tight. The washer's there to ensure that it runs on the inner race of the bearing and doesn't run on the face or so the bearing is doing its job properly. Those bearings, I just put them on the edge and just clamp them in with a clamp. If you have a vise, it's a bit more gentle. That'll go on. We'll pop on the other washer. We'll put on the other wheel. Something to note with these 2 wheels, they need to be in line with the gear teeth. So when you do one up, you just need to ensure that these 2 teeth are not like this. They have to be in line because they'll mesh with the track. The other one we need is the M8 diameter 8 shaft, 100mm long. You'll need 2 of those per side because you have idler sprockets at the top. So I'll take one of those, another one a washer. We'll pop that in. We'll go from the outside because I can't do it from the inside. 1. Taking that out, of course. Do this one up. And again, if I can do this one-handed, you could build a Wally even if you were the one-armed man. I don't know if I'm showing my age there, but for those of you that are fussy, not old like me, my kids say I'm old, a balanced system. What a catch. A balanced system. The weight of that nut and the threaded piece of the grub screw is going to make that weigh down. So if I make a balanced system, I would put this one at the top. These just have to be firm again. And then ideally when I go to spin this now, again, don't overdo these. When I spin that, it should be pretty balanced. If there's a little bit of wobble in the wheel, it won't matter too much. The treads will sort that out when they get a bit of tension on them. Again, so that will be down the bottom by the weight. Put this one at the top. And the cover was just to allow for the head of the bolt to stick out, so it just had to come out a little bit further. I'll just put a drop of hot glue when I glue that in. Shouldn't need to come out very often. And that's the track system together. Copy and paste over to this side, run your wires in the back, and like I said, I'm not going to go fully into electronics. I'll give an overview when I'm done mine. And the last thing we'll talk about is the chassis frame. A couple of dimensions on this one. This large piece at the bottom here. So this bottom member, I'm just running a tape measure from one side to the other. This is going to be, I made mine 590 millimeters long, or 23¼ inch. That gave me about 10 millimeters from the track width, when the track's on here it's a little bit further in, to the inner edge of the body. I didn't want it too close. Like with any system, there's going to be a little bit of flex, so I didn't want it to be too tight. The other pieces, the cross members that are on here, two of these are 300mm long. The center line here, put a square on here and just mark the center, and then I could measure out to each edge where I wanted the tube to be. The distance across these two, outside to outside, is 345. And what that allowed for was that these two dowel pins for where I drop my body on the frame at the moment, I just located those. I'll show you. So this is in the body, and that's where I have those 4 pins. They're just M4 all thread, and the springs sit underneath. I'll have to put a bolt on the top here because I don't want this to have the chance of Wally getting too much momentum and tipping forward and actually coming off the top of that. This is just a screw-in piece at the moment, 2 screws, one underneath and one at the top, so that I could totally customize these, or if someone has a different design or different springs, you can adjust that to suit. I'll probably end up putting maybe a larger diameter bolt in there, or threaded rod, and then I can get away with some larger diameter springs and stuff, and have a spring underneath and a spring above. It just means that I can have a nut at the top here, and that's a double acting spring to try to keep this in equilibrium. If you just have a spring at the bottom, it's just bouncing down on the spring and just trying to push back up to the top all the time rather than try to keep it centered. Isn't that right, Wally?
Wow.
Yes, you'll get your track back soon. Okay, these brackets, again, they're 3D printed. I printed them pretty much solid. They're small. I'll see how they go, whether they break. And this bracket here has heat inserts in the top piece, with some screws, and I haven't put them in, but I could put some M4 T-nuts in here and have that a bit more strength. I'll have to sort of lay it on its side to be able to get them in to line up into the hole now, but definitely something that I can do to try to stop any movement of this under tension. And that's the track.